Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 44 from the Smith Organic Chemistry textbook. And this problem asks us to draw the 11 different aldehydes that can fulfill the formula C6H12O. And we're told to count stereoisomers as different aldehydes. And so there are actually 5 unique aldehydes and then 3 sets of 2 enantiomers each. And so I'll start with the unique ones. Oh, pardon me. And we are also asked to give their IUPAC names. So the most obvious one is going to be just a straight chain, 6 carbon. 1, 2, 3, 4, 5, 6. So this is going to be hexanal. Okay, so that's really the most basic one. So then we can also envision this as a 4 carbon chain with an ethyl branch. So like that. And that's going to be 2-ethyl butanal. So 2-ethyl, because we have an ethyl substituent at the 2nd carbon. And then butanal, because it's a 4 carbon chain ending in an aldehyde. So next, rather than doing 2-ethyl, we could do 2,2-dimethyl. So it's going to be similar. So it's going to be a butanal again. And then instead of an ethyl group, we can just do 2 methyl groups. So that's going to be 2,2-dimethyl butanal. Okay. So we can also draw this as a 5 carbon chain derivative. So it will be a pentanal. One, two, three, four, 5. And then we would want to put a methyl group on carbon 4. And so, of course, that would make this 4-methyl pentanal. Okay. And then so lastly, for these unique ones, we could also, so just like the 2,2-dimethyl butanal that we drew earlier, the third one that I drew, we could also put our 2 methyl groups on carbon 3 instead. And so that's going to make this just 3,3-dimethyl butanal. So 1, 2, 3, 4. And then our 2 methyl groups on carbon 3 instead, as I said. So this will be 3,3-dimethyl. I apologize. I'm not sure what's going on with my my stylus here. So 3,3-dimethyl butanal. Okay. So that's our 5 unique ones, and then the remaining 6 are going to be 3 sets of enantiomers. So so this molecule is going to be 2R23-dimethyl butanal. So 2R 2, 3 dimethyl butanal. And of course, there's no space between the dimethyl and the butanal. I just want to try to save some room here. And so, of course, next we should draw the enantiomer, the opposite stereoisomer. So everything's going to be exactly the same, but this methyl group on carbon 2 is just going to be dashed instead of wedged. And so this guy would be 2s. 2, 3, dimethyl butanal. Okay, and so that's our first set of two. Our second set of two, similarly, is going to be pentanal derivatives with just methyl groups at the 2 position. So that's going to look like this. 5. So this will be 2, oops, no comma there. This will be 2R, 2-methyl, pentanal. And then, of course, its opposite will just have the dashed methyl group there, and will be 2s. 2s, 2-methyl pentanal. Okay, and rather than try to crowd in the last two, I'm just going to put them on a second page here. And so this is going to be another pentanal derivative, but we're just going to put the methyl group on the 3 carbon instead. And so there's our aldehyde, 1, 2, 3, 4, 5. And so this time, this is going to be 2, or certainly not going to be 2. I just said we're putting it on carbon 3. So this is going to be 3s this time. So 3s, 3 methyl pentanal. And then, of course, its opposite. Is going to be dashed, and this will be 3R. Oof. 3R, 3. I apologize. I'm experiencing some lag, and it really makes it difficult to write. So 3R, 3 methyl pentanal. There we go. So, okay. And so that's all 11 of them. Yeah, so I would say if you encounter a problem like this, start from just the straight chain version, and then start moving 1 or 2 carbon groupings around to see how many different isomers you can make. And then just remember, if you're told, as we were here, to count the stereoisomers as unique molecules, just remember to include both enantiomers for each. And so that's the answer to chapter 21, problem number 44.